Afternoon, everyone. Myself is Sachin Kumar and lecturer for Department of Mechanical Engineering and College of Polytechnic, Noida. Today we discuss about the topic of thermodynamics, and it's a very important topic for a student of Polytechnic, also as well as BTech student. So first, we will define a thermodynamics. Thermodynamics means thermo means related to temperature. Means we have find out how the energy can convert to one form to another form, and how this energy is utilized, how much energy is utilized for work, and the efficiency of every cycle. This is the thermodynamics. First, in this diagram, we see about the boiler, turbines, pump, and condenser. We can see how boilers, how much energy is consumed, and how many work output for turbines. And thermodynamics means to define the how much quantity of amount of heat we can utilize, and this utilization of use energy we have discussed in case of thermodynamics. Thermodynamics is many laws. First, zero law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. All the law have discussed about the thermodynamics and content. Thermodynamics and heat and mass transfer topics are related to the heat, but in case of thermodynamics, how much heat we utilize in case of thermodynamics, and heat and mass transfer, the how much heat to flow in the process we are discussing thermodynamics and heat and mass transfer. So first about describe thermodynamics. Thermodynamics, we have described the system, surrounding, and boundary. First, we have defined the system. System means in this portion we can a quantity of matter of a region of space to study. जिस स्पेस में हम कोई स्टडी करना चाहते हैं, that space is a system. Around if we assume a room that work in any process, isotropic, enthalpic, and isobaric process. So if any process follow in any room, outside this room is called the surrounding. System and surrounding, the mass of region outside the system is called the surrounding. Between system and surrounding, we can consider the boundary. Boundary means boundary may be imaginary boundary, may be real boundary. So system means any process, any reactions we follow, we can consider that region, that is the system, and outside the system we can count the surrounding. And between the system and surrounding, that is boundary, maybe is a real boundary, maybe imaginary boundary. So thermodynamics, we have defined system, surrounding, and boundary. After that, we have discussed about the type of system. Which systems we can use in thermodynamic system? First is isolated system. Isolated means neither mass transfer, neither energy transfer between system and surrounding. System and surrounding, there is a no transfer between mass and energy. Example for coffee in a closed system, well insulated thermotic bottles. First, isolated means neither transfer mass, neither transfer energy between system and surrounding. Means system और surrounding के बीच में किसी भी तरह का mass और energy का transfer नहीं होता. That is called the isolated system. After the isolated system, we can define of the closed system. Closed system means only energy transfer, not a mass transfer. In case of a closed system, only energy transfer and not mass transfer in system to surrounding. This we can define the isolated. After that, closed system. After the closed system, we can define as the open system. In case of the open system, both heat and mass transfer are also transfer between system and surrounding. Means if a heat and mass transfer between system and surrounding, that is called the open system. So we have discussed about the in isolated system, closed system, and open system. We can consider heat and mass transfer. If heat and mass transfer not transfer in system and surrounding, we can call the isolated system. If in case of a closed system, only heat transfer between system and surrounding. In case of open system, between heat and mass transfer for the open system. In the first diagram, we can see the turbines, boilers. We can this and that is an open type of a system, because in this type of a system, heat and mass transfer to be considered, because heat and mass are also transferred for this type of a system. So after that, we have discussed about the property of a system. Property means if any specific property of a system is a measurable characteristic of a system that is in equilibrium. Means two type of properties in case of thermodynamics we have discussed: intensive properties and extensive property. Property means if any substance has some specific pressure, specific volume, enthalpy. We call all the properties of this type of properties, intensive and extensive. How to define this? That is intensive property and extensive property. It is a very simple process. First, we consider a room, a specific region, means some volume V, mass M, temperature T, and pressure P, maybe density D of this room. Divide this room and this region into equal parts. Then if two equal parts, then half portion we can consider m by 2 and m by 2. If we consider volume, that v by 2 and v by 2, means divided to equal parts. If temperature we have considered in a single portion, that is temperature T, and another second portion is temperature also T, not T by 2, T by 2, means that property is independent about the mass is called the intensity property. Means temperature, pressure, density, all is the intensity property. Because if we have divide two equal parts in a room, and the first part's initial temperature is T, after the portion of two portion, the first portion temperature also T and second portion also temperature T, means not divide T by 2, T by 2. But in case of a volume, if a room and any region divide two equal parts, the volume is divided by V by 2 and V by 2, means volume is divided to equal parts, but temperature and pressure not divided. So intensity property is that type of property is depend on the amount of mass, means independent of amount of mass. So temperature, pressure is intensity property. Extensive property, which is directly to the mass, means volume, energy, and enthalpy. This is the extensive property. So intensive property, extensive property in a thermodynamics, we have discussed that about that. So in first we have the state. If any process they start at a state, a set of property that describe the condition of a system, means if we consider a system, that system has some specific temperature, some specific volume, some specific enthalpy, some specific entropy also. So that is called the state. And thermodynamics equilibrium means if a system has a thermal equilibrium, mechanical equilibrium, and chemical equilibrium. We have discussed in the next slide what is the thermal equilibrium. Thermal equilibrium means the temperature with the temperature difference between the two systems equal to zero, means not flow temperature, because heat is flow always high temperature to low temperature. Mechanical equilibrium means no external force, means in a case of stable equilibrium, the total force equal to zero, and dynamic equilibrium means force on momentum of the system equal to zero. And also we discuss about the chemical equilibrium. If three systems, three equilibrium condition in satisfy thermal, mechanical equilibrium, chemical equilibrium, and thermal equilibrium, that is called the thermodynamics equilibrium. So state means if any properties, any state, we can define some temperature, some pressure. In this diagram, we can say the initial state one, the some volume is 1.5 mq, temperature is 20 degrees centigrade, and mass is 2 kg. After the second state, the volume also changed because it's expensive process. The volume is 2.5 meter cube, and temperature 20 degrees centigrade, mass 2, means the one is changed one state to another state. So that is state equilibrium process. State and equilibrium. How to define the process? First, we consider process means changing one state to another state. Means if we initially some temperature, pressure, and temperature, then any process follow. Means isobaric process we follow isothermal process, isentropic process, and go to the second stage. And that stage some different temperature, some different pressure, and some different enthalpy. So process means start to some initial state and go to the another point. So that is any process. We can use any process for come to one state to second state. Means isobaric. Isobaric means the process pressure is constant. Isothermal is the temperature is constant. Isochronic means volume is constant of that process. Isentropic means enthalpy is constant. Different processes we can follow to change the state to one state to second state. In case of the thermodynamics, we can use a different type of process to go to state 1 to state 2. And that we discuss all the processes we have discussed in explain next slide. That first we discuss about the isobaric process. We can discuss in next previous slide. Isobaric means the pressure is constant. If we go to one state to another state, that pressure is constant between 1 and 2. So pressure means how to pressure. If initial pressure is P1 and second pressure is P2, the changing of pressure between two is 0. And volume V1, V2. If you find the work done of this process, then find P into delta V. Means area of the P diagram, we can go the process is called the work done, and this is P delta V. The area of this diagram, we can go to we can find the work done of this process. In case of a isobaric process, means pressure is constant and pressure is work done W equal to integration P into delta V. So next we have discussed isochronic process. In case of isochronic process, the process, the specific volume means volume is constant. If volume is constant, so delta V equal to 0, so that work done of this process is equal to 0. We can see the diagram, diagram, only a vertical line, so means area is 0. So isochronic process means specific volume is constant, that means the volume is means the work done and this process is 0. Isothermal, in case of isothermal process, the temperature is constant, and find out the work done is equal to PV into ln T2 at T1, means P delta V integrate this one, and we can find out the work done of this process. So next we have discussed about process. We can discuss in previous slide all about the process: isobaric, isothermal, isenthalpic, this process, how to find out work done and heat. So next we discuss cyclic process. Means cyclic process means if we start any process any state and return to come to back to that state, means आपने अगर कोई process किसी पॉइंट से स्टार्ट किया और रिटर्न उसी पोजीशन पे वापस आ गया, दैट इज साइक्लिक प्रोसेस. ए सिस्टम, in case of a process, we can go to same initial position. If we can start process pressure, something pressure T1 and T1 and some specific temperature T2, so and final out go to the same process, same temperature, that is a cyclic process. So that is a cyclic process. Next we will discuss about the reversible process. This is a very important question. What is a reversible process? Can all processes be reversible or not reversible? So first we define out the reversible. What is a reversible? Reversible means if any process start for point 1, some specific temperature, some specific pressure, some specific volume, and go to the process 2, yani means some temperature, go to the stage second, and means something temperature T2, pressure P2, specific volume V3, for given any process, means maybe we have taken isentropic process, isobaric process, isochloric process, but in this case and return position 2 to state 1, state 2 to state 1 without affecting the surrounding, means the surrounding pressure, temperature, and specific volume is not same. This is called the reversible process. We again repeat, if any process start for state 1 and go to the state 2, means state 1 something temperature T1, T2, T3, and go to the state 2 temperature, space temperature T2, T3, and T3 with any process means we can use isochloric, isobaric, isothermal process, but in this case the surrounding of the system is not affected, means the temperature of system surrounding temperature T2, P2 and all the same, means return to means अगर आपका कोई प्रोसेस 1 से स्टार्ट हुआ है और सेकंड पे गया है और सेकंड से 1 पर रिटर्न आया, सराउंडिंग पे कोई इफेक्ट नहीं पड़ता है, दैट इज कॉल्ड द रिवर्सिबल प्रोसेस. And if the surrounding temperature, pressure, and all the properties are changing, that is called the irreversible process. In all the processes on thermodynamics, we have considered reversible process, but actually this process is not a reversible process. It is a irreversible process due to many causes. It is a friction, and other effect to affect the process of reversibility. So this is the reversible process. And we can define the adiabatic process. A process which has no heat transfer in and out of the system, it is considered to be a perfect insulated. Adiabatic process means a process with no heat transfer between in and out, which is called the adiabatic. Isentropic process, entropy is constant in this process. First we define what is the entropy. Entropy is nothing but it is a degree of randomness. Means if a room, we consider at a room, and the system, all the matters are organized in a good way, it is a no disturbance, this entropy is very low. If the atoms and molecules are doing very fast, very atoms and molecules are very high velocity, then the entropy is very high. This entropy means a degree of randomness. If disturbance is high, the entropy is high. If disturbance is very low, so entropy is very low. Entropy means degree of randomness. So isentropic process, the entropy of the system is constant for this process. When we can go to state 1 to state 2, so entropy is constant. Polytropic process we can consider PV to power n is equal to constant. We representing enthalpy. Throttling process means the enthalpy of the constant, means if they consider a process go to state 1 to state 2, the enthalpy of this system is constant, that is called the throttling process. So discuss adiabatic process between heat transfer, not a heat transfer between in and out. Isentropic means entropy is constant of this process, and polytropic process, all the process undergoes a reversible process which taking the heat transfer, PV to power gamma is equal to constant, is the polytropic process. And throttling process means the enthalpy is is no change enthalpy, no change in the enthalpy. Initial position, the enthalpy is same, and final position is enthalpy also same. So we can find that is the throttling process. So first, and then we discuss about the zeroth law of thermodynamics. Zeroth law of thermodynamics means if a body is thermal equilibrium to a body, thermal equilibrium to body B, and that body A is thermal equilibrium also body in C, then B and C also in thermal equilibrium. Means if a body A is thermal equilibrium to body B and body A is thermal equilibrium with body C, so automatically body B and C are thermal equilibrium to each other. That is called the zeroth law of thermodynamics. It is the application of measurement of temperature. Zeroth law of thermodynamics is the we can consider the example of zeroth law of thermodynamics. So that is the measurement of temperature of the zeroth law of thermodynamics. So this is zeroth law of thermodynamics. Let's discuss about the point function. So point function means all the property. If any state we consider pressure, temperature, V, that is all called the point function. So if any state we consider to specific pressure, temperature, if we consider pressure, temperature, specific volume, specific enthalpy, that is called the point function. And path function means heat and work. Heat and work are the path function, because it is not a point function. So point function and that is a point function and path function. So a process, if any one and one property of the system undergoes change due to energy of mass transfer, we can say the system undergoes a change of the state. Means any system to point 1 to point 2 change, that is called the process. Means go to the isentropic process, isenthalpic process, isobaric process, isenthalpic process. If system state change means go to state 1 to state 2, and that state is changing for taking any process we consider isobaric, isothermal, isentropic, adiabatic process. So then this is called the changing of state, that is called the process. So all the curve, if we can consider next slide. Thermodynamics equilibrium we have discussed in the previous slide. What is thermodynamics equilibrium? Means if any system we can thermodynamics equilibrium if satisfy three conditions. Three conditions means that is mechanical equilibrium. Means mechanical equilibrium means no unbalanced force. If a system is a static system, we can say force equal all the forces delta is equal to 0. In case of dynamic system, force and moment also equal to 0 in case of a dynamic equilibrium. Means a mechanical equilibrium, no unbalanced force. In this, if no unbalanced force is, then it's called the mechanical equilibrium. Thermal equilibrium means uniformity of temperature between and the temperature flow. The flow of a temperature is go to higher any process higher temperature to lower temperature. Means temperature difference between uniformity of temperature. That means called the thermal equilibrium. Chemical equilibrium means absence of any chemical reactions between not in the system, not absence of any chemical systems. Means koi chemical reactions na ho, that is called the chemical equilibrium. If three equilibrium system, mechanical, thermal and chemical equilibrium system satisfy the condition, that is called the thermodynamics equilibrium. So mechanical equilibrium is if it's called the no unbalanced force available. If non unbalanced force, we can call the mechanical equilibrium. We also discuss in theory of machine how if a system is a static system and dynamic system, how to unbalanced force is convert to balanced force, and using extra force and moment also, that this is a mechanical equilibrium system. So these three systems are used in case of thermodynamics equilibrium systems. So next we have discussed, but in the previous slide we have discussed what is a reversible process. So I again repeat that what is a reversible process means if any process state one point, some specific pressure, some specific temperature and volume, go to the state position 2, some specific temperature P2 and specific volume, go to the any process, means isobaric, isothermal, isentropic process, adiabatic process, and return back to position 2 to position 1 with same process, but without affecting the surrounding pressure, temperature. That is called the reversible process. But actually this is not possible, because all the processes in the thermodynamics we have irreversible process due to friction, heat transfer without infinite temperature difference. This is the cause of irreversibilities. So no friction. If no friction available, that is called we can say that is a reversible process. But actually, all the processes in case of a turbine cycle, gas cycle, heat engine, all the process is called the in reversible process. But we can assume that all the process is a reversible process. The application of thermodynamics we can stick to the turbines, case of gas turbine, Also we use in the Rankine cycle, how to heat use in case of a turbine, and pump, how to heat use turbine to how to produce the work. These boilers, how to consume heat. This all the application of thermodynamics we can study in the thermal power plant, gas turbine cycle, power plant cycle. And so we, in this cycle, we have all the processes we have considered as a reversible process, but actually this process is not a reversible, because if boilers consume to heat due to some friction also consider, taken heat transfer throughout infinite temperature difference, some temperature difference is created between their process. So this is all the process in reversible process. But if you find out the derivation, find out the efficiency, work done of turbines, work done of heat transfer to boiler, net work done, so and we can consider this is procedure reversible process, and we can assume between the boilers, turbines, there is no friction available. So these applications of the thermodynamics in case of a gas turbine, power plant turbine, heat turbine, steam turbines, all the turbines we can use in the application of thermodynamics. So next we will discuss about the what is heat. Simply heat is the form of energy which transfer without transfer of mass from one body to another body. If we taken the system to heat, that is taken the positive heat adding into the system, Q is positive, and heat rejection from the system, that is Q is negative. Heat is always a path function, we have discussed in the previous slide. After we find even work done, we can find out the W equal to F delta S, integration of P delta V. Also all the process in case of a isobaric, P delta V, isochloric, isothermal, all the process we find out the work done. If the volume is constant, initial state the volume is V1, also after the state 1 to state 2 the volume is V2, means the volume change is 0, so work done also we can consider delta W is equal to P delta V is equal to 0, means volume change is 0, so work done also in the case of 0. So we have discussed in the previous slide how to find out the work done of every process, isobaric, isochloric, isothermal, isotropic, isenthalpic. So this is work done for any system we can find out. After the work done, this is a difference between the heat and work. Heat can only transfer when the difference of temperature between the system and surrounding means if the heat is always transferred between higher temperature to lower temperature. If a temperature difference is created between the two systems, higher heat is flow always higher temperature to lower temperature, but work transfer can take place without the temperature difference. This is the first difference between if a two state the temperature difference, that means heat is flow to higher temperature to lower temperature. Work transfer can take place even without temperature difference. In constant volume process, we have discussed work is not taken, where in case of a heat transfer, however the heat can be transferred, means if volume is constant, so work is not take place, and there but heat is transferred. So this is the difference between the heat transfer, heat and work. So we can discuss in the previous slide is the zeroth law of thermodynamics. Zeroth law of thermodynamics means if body A is thermally equivalent to body B and body A is thermally equivalent to body C, so B is C is automatically thermally equivalent. This is called the zeroth. So next we discuss about the first law of thermodynamics. In case of first law of thermodynamics means energy can neither be created and cannot be destroyed. It is a convert to one form to another form. It is the first law of thermodynamics. Means in a cyclic process, closed system, delta Q minus delta W is equal to 0. So if this thermodynamics first law is applicable in the process, delta Q is equal to delta U. Delta Q is equal to delta U plus delta W in case of a process, but in case of a cyclic process, delta Q minus delta W is equal to 0. It simply means energy cannot be created, means energy convert to one form to another form, then cannot be created. Means enthalpy, we can simply show the enthalpy is equal to U plus PV, means enthalpy is converted to internal energy. Also all the energy form is converted but cannot be destroyed and cannot be created. So first law of thermodynamics is applicable if in case of a cyclic process. Cyclic process we have discussed about if any process start to point 1 and come to return to that same point, that is called a cyclic process. If we apply for the first law of thermodynamics in a case of a cyclic process, so delta Q minus delta W equal to 0. In case of any process, single process, go to state 1 to state 2, and some we can then delta Q is equal to delta U plus delta W. Some work done, some internal energy, and delta Q is equal to which energy given to the system. Yeah, maybe go to the systems and internal energy also, delta U is equal to internal energy of the system, means point 1 to point 2 go to the how which internal energy is converted, and delta W equals work done. If we case of any process we consider isentropic, isobaric, isothermal, how much work done go to the system. This is called the first law of thermodynamics. It's applicable for cyclic process as well as in case of a process. In case of cyclic process, internal energy of delta U is equal to 0, delta Q is equal to minus delta W equal to 0, and in case of cyclic, in case of a simple process, delta Q is equal to delta U plus delta W. The algebraic sum of total energy transferred to it is a heat and work is 0 in case of a closed system. And this is the first law of thermodynamics. So in this case, we have discussed about the thermodynamics. Thermodynamics, what is the process, isentropic process, isobaric process, open system, closed system, application of thermodynamics in case of a heat, in case of a power plant, steam power plant, gas turbine power plant, and about to discuss the zeroth law of thermodynamics. And after that, we have discussed about zeroth law of thermodynamics and first law of thermodynamics. This is the simple application of thermodynamics for beneficial for the student of Polytechnic. So next slide of thermodynamics, we have discussed about the briefly discussion about the first law of thermodynamics in case of open system. How to open system will be applicable for the thermodynamics first law, after the second law of thermodynamics, and third law of thermodynamics. So thank you very much for the listening this lecture.